Today we're going to talk about optical stimulation of mitochondria reduces blood glucose levels. Let's talk about this article that was just published on August 28th on this website that actually carries non-peer-reviewed literature, which is still the situation here. So why I bring this up today is because I want to talk a little bit more about light and diabetes. A lot of times people think that diabetes is simply the end result of just diet. But in fact, diabetes is a multifaceted disease, unfortunately, or fortunately, depending on how you want to look at it. And a lot of things like exercise and activity can be helpful, as well as exposure to sunlight. So we're going to talk about that here. Now, before we do that, we have to talk a little bit about the mitochondria. So inside each cell is a nucleus, but there's also these tiny little organelles called mitochondria. And they are the parts of the cell that produce energy in the form of ATP. And the way they do that is by breaking down fats, sugars, and proteins. So these things go into these little mitochondria, and out comes something called ATP, which is energy. Also, what comes out is carbon dioxide. What we want to look at today is see how optical stimulation of cells can actually change that. Actually, what we'll see is potentially going up on ATP, and as you start to use these things, they start to go down. And specifically, we're going to look at blood sugars, which has to do with that. So this looks like a really busy slide, but I want you to just bear with me on this, okay? So here we have the mitochondria. And that's this thing right here, okay? And as I said, there's fats and proteins. But we're going to talk about sugar, and that's glucose right there. So glucose is broken down in the cell, this should be a Y, to different intermediates, and it basically goes through the mitochondrion, through this something called the citric acid cycle, and it makes these reducing agents, and then it goes to this part of the mitochondrion. But what comes out is basically, as we said here, ATP. But I want you to notice something. Obviously, we have oxygen going in. That's why we need to breathe. It's because oxygen is necessary for all this to happen. But notice here, carbon dioxide is a byproduct. Okay? Keep that in mind. Here's the ATPs that are coming out. That's the energy. Oxygen is going into the system. Carbon dioxide is coming out. And that's why we breathe in oxygen and we breathe out carbon dioxide. That's how we burn energy to get this. We burn fats, proteins, and sugars to get energy. Now, what we're going to see here is the scientists hypothesize that light, specifically red light, actually can penetrate down into the water here that's surrounding this pump that's making the ATP, and it can make it more effective so that it actually works better. Now, of course, you can see what's going to happen if it makes it work better is that the carbon dioxide levels should go up and the glucose levels should go down. Okay, so let's take a look and see if that happens. So we're going to go through this study bit by bit. So they say here in the introduction that red light stimulates mitochondrial respiration. That's exactly what we were just talking about, shifting its metabolism. And this is known as something called photobiomodulation. That's a long term. Look that up and you'll start to see that a lot of people now are using photobiomodulation for a lot of different diseases, including multiple sclerosis, including Alzheimer's disease, Parkinson's disease, even long COVID. Okay? So light, specifically red light, at this wavelength alters cellular respiratory rate, increases membrane potentials, ATP production, and reduces this reactive stress and inflammatory markers. So they're basically saying here that light is really important for your health. This results in improved sensory and motor function, including aged human color perception. That means people who are older can actually see better when they are exposed to red light, even in the near-infrared spectrum. They say here that the nanoscopic interfacial water layer surrounding the pumps that we were talking about actually improves when there are energy transferred to that water, becomes less viscous, allowing that rotator pump to achieve greater momentum and increase ATP production. So they say an increase in ATP production requires more fuel. Since glucose is the primary fuel in animals, they would think that the glucose would actually go down. And these authors have already shown that in bees. Okay, so now they want to show it in humans. So that's what they tried to do here, to look for a non-invasive, non-pharmaceutical way of dropping blood sugars. So what they did was they took 30 subjects and they randomized them. That means they put two groups in, and this is a great way of eliminating confounders and biases, is when you randomize. There was two groups. There was a placebo group and what we'll call the 670 group. The 670 group is the group that's going to get eventually exposed to red light at 670 nanometers. So that's the wavelength specifically. Okay, placebo on the left and the 670 group on the right. Now, what they did next was they took a baseline measurement in both groups without doing anything. So these should all have been the same type of thing. And we'll call this the no placebo GGT and the no 670 GGT. What's a GTT? GTT is the glucose tolerance test. So here in the placebo group, they didn't give them any placebo. They just did a glucose tolerance test. And over here in the 670 group, they did not give them any 670. Okay, so they're just sitting down in a room and they're getting their blood drawn after taking a bolus of glucose as part of the glucose tolerance test. Okay, then what they did was they waited no more than 7 days and they brought them back in. And this time in the 670 group, they put this light on their back that they could not see. There were goggles on, and they shined 670 nanometer light on their back. And then, a short time later, about half an hour to an hour later, they measured the glucose. Over here, they did exactly the same thing. They strapped the thing on the back. They put goggles on, but they just didn't turn the light on. That was the only difference, is they did not turn the light on. So you really have four groups. You have two groups in the placebo, and you have two groups in the 670. Let's take a look now and see what happened. Okay, so here we are looking at the placebo versus the 670. Which two are those? We're looking at this one versus this one. And we're trying to see here what this did to glucose. Notice that at 3 different measurements after the glucose tolerance test that started here at 0, that at about 45 minutes and 60 minutes and then at 90 minutes, there was a statistically significantly lower blood glucose. And remember that each point here is about 18 milligrams per deciliter. Okay, this is the European system, so just multiply. This is above the baseline. Notice how much above the baseline the blood sugar went for the placebo in green, and how much lower it was just being exposed to light. So what is this telling you? It's telling you that light exposure can actually mitigate super high blood sugars. It'll actually bring it down. If you notice here at about 1 hour, this was about 2 points on this scale, which would be about 36 milligrams per deciliter. That's quite a bit. Probably the efficacy of a medication there. All right, here's our group again. Let's take a look now. This time we're going to look between these two groups and see if there was a difference. Remember, they just did a regular glucose tolerance test by taking in some glucose to see what they did. Then they strapped this light to the back, this device, and they turned it on. Okay, so we're here and we're seeing the full measure of it, and let's see what happened. Again, you can see statistically significant differences along the way. That 670 was very beneficial compared to when that same group did not put it on and turn it on. All right. Now what we're going to do is we're going to look at these two groups. Okay, now this is without the thing strapped to the back, and this is with it strapped to the back, but with it turned off. Okay, there shouldn't be much of a difference. And sure enough, there is not much of a difference. In fact, none of these points are statistically significantly different from one another. All right, and now finally, let's look at all four groups. So here's the maximum glucose level reached. Okay, this one is the placebo group that was on the left. This is the 670 nanometer group on the right. This one here is with just the regular glucose tolerance test. And these here are after the lights are strapped on. Notice that those two are not different. This one, however, is different. So what we found here is that exposure just for 15 to 20 minutes, this light could actually mitigate the increase in blood sugar. So you may want to consider this if you are eating, maybe eating outside, eating around with a lot of light. These may be things that are beneficial. Again, this is a randomized controlled trial, so that's the highest level of evidence. And I think we're going to talk a little bit more about that coming up here shortly. All right, so what we did here is we noticed that when we shone light on this area, what happened was they believed that this became more efficient. And when it became more efficient, this cycle was able to spin faster, utilizing the products of blood glucose, which caused it to go down. Now, if that's the case, we should notice that there's an increase in carbon dioxide. Let's take a look and see if that was the case. So again, here's our study design. What we're going to do is we're going to look at these two groups here for measured carbon dioxide output. Let's take a look here. There really wasn't any statistical significant difference across the board. That may have been because of selection, but another way of looking at it would be to look at it as this in the same group. And that's what they did. So they're looking at those in the intervention group that didn't have anything on their back. It was just a glucose tolerance test versus those that had it strapped onto their back and turned on. Let's see what happens. There was one point there which was statistically significant, and that was in the light group. Notice that there was more, not glucose, but more end-tidal CO2. That means that there was more carbon dioxide being made in the middle of the cell, which is in the mitochondria. All right, let's see if there's any difference between these two groups. Nope, no statistical significance whatsoever. So the conclusion of this study is that light given to the body, and it's on the order of being out in the sun for a few minutes to 20 minutes to 30 minutes. It's unclear exactly how much you need, but we do know that red light in this spectrum, which is visible, seems to confer to the body a switch in its ability to metabolize glucose. It increases its ability to metabolize glucose, and therefore it causes the blood glucose levels to go down. So getting outside, we don't know how long this is going to last for. So if you go outside in the morning before breakfast and turn on these sensors to get your body able to metabolize more and give more energy, I think you're going to actually have more energy. You'll have lower blood glucose levels, and you'll feel better. So getting outside, getting up in the morning, and getting that red light, that near infrared light too, is going to be better. Now, that reminds me of a study that we did, looking at this in Europe. So here was an interesting study that they looked at the bright sunlight and the cardiometabolic traits of two European population-based cohorts. So they did this study in Oxford, England, and also in Leiden, the Netherlands. And the total was about 13,000 subjects. So it was a big study. And what they did was they tested their blood on a particular day all throughout the year. But with each subject that came in, they looked at the weather report for the previous 7 days. And they noted how many half days of sun there were in the previous 7 days. And they noted that there was an association between the number of days that there was sun in the previous days and the improvement in their cardiovascular scores, their diabetes, their score of diabetes, insulin resistance, that the people that had more sun had better metabolic health. So what's really interesting about that is that this is something that you can do almost immediately and right away to get the full benefit of sunlight on your metabolic health. Literally, it could start today by making changes in your lifestyle to making sure that you're getting outside in the morning, if possible, and getting some of those sun's rays so that it switches your metabolism. You know, on our channel, we've talked about long COVID. Many people have long COVID. And what they're showing here is that people who have long COVID, specifically these people over here, notice how it's red there, but it's blue over here by the arrow. What that's showing you is that all of these fatty acid enzyme metabolites are slowing down, it seems, in long COVID, which is PASC. What does this mean? This means that it seems as though people with long COVID tend to not be able to metabolize fats as easily as they did before they got COVID. Some people may notice that after COVID, it was harder to lose weight. And it may be because their mitochondria was damaged. What I would recommend if you want to repair your mitochondria, if you want to get good mitochondria that's very efficient and works very well, number one, I would make sure to get outside to get a wide swath of the spectrum of the sun to be able to do its work. That's number one, okay? Number two is you need new mitochondria if you've damaged your old ones. And the best way is to help your body replace itself of the new mitochondria. So that happens at night when you're sleeping. But it will not happen if the body has recently ingested a meal. So it's extremely important that you try to have supper, dinner very early, potentially before 6 o'clock, so that you're able to get in a fasting state before you go to bed. That's really important to understand. And this is a long COVID video that we actually put to our website and to our YouTube channel called MegCram. And it talks about going through the research of this. But all to say is that we know that long COVID, lack of energy, diabetes, dementia, Alzheimer's disease have a rooting in problems with the mitochondria. And what we're saying here is that light may be a real factor and benefit in terms of getting over some of those diseases. So the bottom line here is it would be best to get outside. If you're concerned about sunburn or skin cancer, you can cover up because this light, the infrared light specifically, can penetrate through those clothes. But the best thing to do is to get natural light, especially in the early morning hours when the sun is coming up, and in the late evening hours, because these are the hours where ultraviolet radiation, which causes the skin cancer, is at its lowest. And I hope this has been helpful. If you have any questions, please send us emails, text. Thanks for joining us for True Health Tuesdays.